Hello, I am Channa Bankapur. I'm going to discuss my solution to the LeetCode problem, linked list cycle 2. It's today's problem in the October LeetCoding challenge, and the problem definition is as follows. So we have a linked list, maybe like n nodes in that, and n being 4 in this example. And normally the last node, nth node, points to a null pointer, and in that case we call it as a null terminated linked list. And in this problem, it might be pointing to some other node in the linked list, and that creates a cycle, right? And they are expecting us to return the pointer to the node that where the cycle begins, right? If there is no cycle, it should be a null terminated linked list. In that case, we're going to return null pointer, right? So that's what the problem is. And they are asking us not to modify the linked list. The linked list given as an input should not be modified. And a follow-up question is, can we do it in big O of one extra memory? That means not taking more than constant amount of extra memory. So we can actually solve using a brute force method with these constraints in big O of n squared time. So for every node, you see whether that node has already appeared before that linearly, right? And that takes linear time. And so overall, you're going to do it for all the nodes. So that's going to be big O of n squared time, right? But big of n squared is too expensive. So if you want to do it faster, using hash table. So hash table idea is when you keep visiting a node, keep it stored in the hash table, and whenever you visit a node, see whether it is already available in the hash node. If it is there, that means we are visiting the same node second time, and that has to be the first such node, and that's going to be the starting node of the cycle. And the time it takes is going to be big of n on an average case, because it's a hash table, and it takes big of an extra space, right? But if I use a balanced BST like AVL tree or red black tree, so we can do it in big of n log n time in the worst case, right? But this also needs big of an extra space, right? So we did not actually follow this constraint. But what if you want to do it that way? So let me use another idea. So we have one idea to detect whether there is a cycle or not. That idea is very simple. So you start with something called fast pointer and slow pointer at the beginning. And slow pointer in every iteration goes to the next node, and fast pointer goes to next of next. That means fast pointer travels twice the speed, right? At some point, if there is a cycle, if there is no cycle, fast pointer is going to hit null, and then we say that there is no cycle. If there is a cycle, fast and slow pointer at some point are going to approach, or they're going to be same. That means there is a cycle. That's a cycle detection, but the detected point may not be the beginning of the cycle, right? That's all we have here. So can we use that idea and then try to solve it? So I'm going to generalize this problem. Suppose there are some, m number of nodes before this cycle, right? So in this case, this is m number of nodes, which is 4. And there could be some n number of nodes within this cycle, right? So let's take it as, maybe 1, 2, 3, 4, 5, and maybe 6, right? So no, actually this is 5. So there are 5 nodes here. So n equal to 5. Right? So in this case, fast pointer, slow pointer idea is going to start from here. So both fast and slow pointers are here, and every time fast pointer goes to next of next, and slow pointer goes to just next, right? So by the time slow pointer reaches this point, that means it has traveled isn't it has gone through m iterations, right? It's not that we can catch that event, but when it actually reaches this point, let's see where does start fast pointer is going to be. It must have traveled twice the number of iterations. So it's going to be 4 here and another 4, so which is going to be here, right? This is where the fast pointer would be. In this case, n is greater than m, so it is very clear it hasn't completed more than a cycle. But what if n is lesser than m? In that case, fast pointer might have completed more than one cycle, right? So let's see how far it's going to go. Instead of saying that it's going to go so normally m plus m is the distance fast pointer travels. But if you want to see how far is it from the beginning, if n is smaller, I might want to equate it to m plus something which is m mod n, because it's a cycle of length n. So it's going to be m mod n, and let me call this as p. So it is going to be m plus p, right? So that is the distance of fast pointer from the beginning, right? So and that is where actually it is when slow pointer reaches the beginning of the cycle. So we cannot catch this event, but what is the event we catch is going to be when fast and slow pointer are going to be same, right? They are meeting. In that case, let's see this, the fast pointer is like, n minus p locations before this beginning, which is slow pointer. So if you go another n minus p iterations, slow pointer is going to go n minus p. This, in this case, n minus p is equal to 1. So slow pointer is going to go by another n minus p iterations. By that time, fast pointer is going to catch up, right? Because it goes in the double, it goes double the speed, right? So this is where we are at. So that means we are at m plus n minus p, distance away from the beginning, right? That's where both fast and slow pointers are meeting. All right. So now let's see how can we find the beginning of it. Now from here, suppose I start another pointer, maybe slow pointer again, because slow pointer is not useful anymore. So I'll start slow pointer again at the head and try to go over by m number of iterations. At that time, and if fast pointer now this time maybe it is not going faster, it will go, go to the next in every iteration. In that case, this will also travel m number of locations, and now slow pointer is also traveled m number of locations. This is where fast is at, and slow is at m, which is the beginning of the cycle, right? Beginning of this, the cycle we want to find. Now look at this. What happens to m plus n minus p plus m? So this m is obviously, if m is lesser than n, it is going to be m itself, or if m is greater than n, we have already seen this is equivalent to p. So I can replace this with p because the fast pointer is already within the cycle. So that is going to be m plus n minus p plus p. So PP cancels out. That means we are at a distance of m plus n in the beginning, from the beginning, and n is the length of the cycle, right? That means in terms of the cycle, we can cancel that also out, right? N mod n is going to be 0. So we are at a distance of m from the beginning. Fast pointer is at a distance of m from the beginning, and slow pointer is also at a distance of m from the beginning, and that has to be the point where, as in that means both of them should actually meet at that point, and the point they meet in this time is going to be the beginning of the cycle, right? So I think this is going to solve. Here we haven't taken anything more than constant extra space, and this works in linear time, that we can analyze little later, right? I'll go to the coding part and then try to show you how it works, right? So here I have handled some base cases here. So in the beginning, if head is pointing to null, or head is pointing to itself, that means it's a cycle of length 1. In both of these cases, head is the answer. And as usual, I'm going to start fast and slow, both of them at head itself. And as so, because either fast is going to be null or fast of next is going to be null, that is when we want to stop. So that means either fast is at null or fast is at the tail of the linked list in a null terminated linked list. We want to go that way. And every time fast goes to the next, and sorry, slow goes to next, and fast goes to next of next. So if they meet, then that means if there is a cycle, we are going to break out of this instruction. If there is no cycle, we are going to break out of this condition. All right. So if we break out of this condition here in the while loop, that means there is no cycle. We are going to check that here and then return null pointer. Right. In this case, there was no cycle. So otherwise, if we pass by that, line number 22, at line number 24, we know that there is a cycle. So now, as we have discussed, both of them are pointing to that in a location which is m plus n minus p distance away from the beginning. So, and fast is still pointing to that location, and slow is going to be reset to head. Right now, we are going to check for when fast and slow meets. It has to meet this time because we know there is a cycle. So we go as long as they are not meeting. But yeah, in this case, fast does not have the meaning of fast because it is also going in the same speed, and slow is also going in the same speed. They are going to meet, right, as we discussed earlier, because after m number of locations, this is equivalent to m, and slow is also moved by m number of locations. They have to meet. So when they're going to meet, both fast and slow are same are they at the same place, and that has to be beginning of the cycle, and I'm returning that, right? So let's see whether it works. The lead code accepts it. So let's see. Okay, let me try to just submit it and see if it works. See, it has accepted. And look at the time complex space complexity is clearly constant space. So what about the time complexity here? If you observe here what happened in these loops, this loop clearly runs for that m number of times. So the total number of nodes is going to be m plus n, right? And m number of times this runs, and this one, it runs for first m and then n minus p, right? P could be as much as m if if n is greater than m, but in the other case p is going to be much smaller number, right? Even if you take it as m, so this is going to be just n, the whole thing is n. But even if this is very little, maybe if you can ignore it, this is still m plus n, which is the total number of nodes, right? So that way, the overall time is still linear, right? So it is m plus m. At the max, it is like 2 plus m plus n. Maybe the whole number, if capital uppercase n is the total number of nodes, we haven't traveled for more than 2n number of iterations, right? But yeah, some iterations has two instructions here, or actually this one has next to next, and this has two of them. But whatever it is, it's going to be a constant here, and that's why the overall time complexity is going to be big O of the number of nodes in the linked list, which is linear, right? That's why it works in linear time and constant space, and that's what they were expecting. All right. So if you have any other simpler way of solving or a faster way of solving, let me know. Otherwise, like the video and subscribe to the channel.